Alright guys, here we go. This is the video lesson for 11-1, simplifying radical expressions. Starting out here with the definition of what a radical expression is, and that is simply an expression that contains a square root. So an expression that contains a square root is a radical expression. Pretty simple there. Starting out here with an example of the square root of AB and just some other ways that you can write the square root of AB. Obviously the square root of AB means the square root of two things being multiplied together, A and B. You could also write it like this, the square root of A times B, if you wanted to separate the AB a little bit more. Or you could write it as the square root of A times B. Or I'm sorry, the square root of A times the square root of B. Now this might make a little bit more sense thinking about an actual number in there. So let's just say I had the square root of 10. You could rewrite the square root of 10 as the square root of 2 times 5. Oh. Excuse me, something happened to my screen. There we go. So the square root of 2 times 5, or that would be the same thing as the square root of 2 times the square root of 5. Again, this simply kind of gets into the idea here that you can multiply two radicals together, even if they're not the same radical, and you'll get an answer just like you would with whole numbers. Root 2 times root 5 gives you root 10. A couple more vocabulary words here to remember is that the actual square root symbol is called the radical, and the actual number or part underneath the square root symbol is called the radicand. So just some vocab that you need to remember while we go through this section. Okay, so the problem number 1 here, the square root of 52, is actually just review for you guys, since you've already learned this in the last section, how we break down the square root of 52 by using a factor tree. And you say, okay, well I got two 2's, so that's going to give me a 2 on the outside, and the square root of 13 is on the inside. Now, that's how we solve these problems. You need to understand also the other way we showed you to solve these problems is to break the square root of 52 down into two square roots that are multiplied together, one of them being a perfect square. In this case we said 4 times 13. And then the square root of 4 is obviously the whole number 2, and the square root of 13 was a prime number, so it doesn't break down any farther. And again, that's kind of the idea of this section, because you can see in the next problems we have a bunch of radicals multiplied together. So let's go ahead and look at number 2 now. 2 times root 24. You could say that I could multiply these together and get the square root of 48. But then when you break down the square root of 48, you're going to be saying 2 times 24, and then 2 times 12. 12 is 2 times 6, and then 6 is 2 times 3. So really you kind of did an extra step of work there by multiplying 2 and 24 together, simply because you were going to break it apart again. But either way here, you got two pairs of 2's, so you have 2 times 2 on the outside. You have that 3 left over, so final answer here is 4 root 3. Alright, looking at number 3, a problem where there's a number in front of your radical already. This 2 root 3, 2 square root of 3, or 2 times the square root of 3. And then the next thing you need to remember is that really technically all of these radicals have a number in front of them. That you could think of this as 1 root 15. Well, you'd multiply this just like you'd think. You multiply the whole numbers together, so 2 times 1 is 2. Root 3 times root 15 is root 45. but then you're going to have to break down the square root of 45. So we have that whole number 2 out there already. So let's just leave that guy out there and don't forget about him. 45 we're just going to re-break into 3 and 15. 15 is 3 and 5. So here, and maybe circling my 2 up here originally was not a great idea. Let's just rewrite that without circling it because that's already on the outside. So here I have 3, 3, and 5. So the 3's come out as a 3, and don't forget there was already that 2 out there. So now you have 6 root 5 as your final answer. Again, something that you might have already picked up on, but you know, if I have 2 root 3 and then times 1 root 15, I know I'm going to have 2 times 1, but I might go ahead and say, okay, 3 and 15, why multiply those back together? Just say 3 and 15. 15 is 3 and 5, so another 3 comes out. Might be an easier way for you to maybe look at that. Again, you're going to kind of have to figure out your own method for this. Number 4, pretty much the same here, except you got 2 whole numbers here. 3 times 4 is 12. Root 10 times root 10 is root 100, which is just 10. So you end up with 12 times 10, which is 120, whole number, no radicals at all. You end up with just a whole number answer there. Number 5, again, everything's the same that we've been doing here really with the simplifying radicals as it was in the last chapter. Number 5 and 6 now get into something that's a little bit different, and that is variables. But again, since we've done this factor tree method all along, the variables really fall right into line with the same way we've been factoring them. So you can go ahead and look at 40 and say, okay, maybe 4 and 10. 4 then is 2 and 2. 10 then is 2 and 5. So you have this pair of 2's that comes out as a whole number 2. Let's write the answer right here. So we got the whole number 2. And then you have this 2 and this 5, which is going to give you the square root of 10. I might need some more room here. So I have the square root of 10 left. But there's obviously going to be other things coming out here. So if you want to look at your x squared, you might think of it as x times x. Your y to the 5th, think of as 5 y's here. And then your z to the 3rd as 3 z's. What happens here is you're again taking out pairs. X squared, there's a pair of x's, so an x comes out. Y to the 5th has 2 pairs of y's, so 2 y's come out, and you're going to write this as, I'm going to need much more room here for my answer. So you're going to write that as y squared, because 2 y's came out of the radical. Again, not forgetting that you got that square root of 10 over here. 2 y's came out, but there was this extra y here that did not have a pair, so it stays on the inside. And then same with the z's. Here's a pair of z's, so a z comes out, and this extra z in here stays in. So 2x y squared z, and then the square root of 10yz is simplifying that radical. Again, another way to think about this is that obviously even numbered exponents are going to be perfect squares, and again, I think we discussed this in class, but if you look up here in the top right hand corner, I'll put this in red, even numbered exponents are always going to be perfect squares. So the square root of x squared is just x. The square root of x to the 4th is x squared, because there are 2 pairs of x's in this if there's 4 of them. Square root of x to the 6th is going to be x to the 3rd, because there's 3 pairs of x's. Same with square root of the square root of x to the 8th. You're going to have x to the 4th. It's just half of the number, the radicand, because there's that many pairs. if you have 8 x's, you have 4 pairs of x's. And then what happens when you have the odd numbers, like 7, well, you just need to think of one less than that. So really, if you have x to the 7th, you're going to think of, this as the square root of x to the 6th, and then an extra x in there. Okay, so actually let me write that on the other side here so I can write my answer there. So you're going to think of this as the square root of x to the 6th times an extra x. Well, x to the 6th comes out as x to the 3rd, so this answer is x to the 3rd with that extra x still underneath the radical. So let's see, I'll put this in blue to change up the colors for you. Let's squeeze x to the 5th in here. Well, if you're thinking of x to the 5th as x to the 4th and an extra x, you're going to end up with x squared with that extra x. So that's kind of how variables work too. You can think of it like that. So maybe applying that method down here for the last example, number 6. I think I've erased the actual 6, but again, there's already a 2 out here, so I'm just gonna write kind of my answer here. Negative 2's on the outside. I'm obviously going to have things on the inside or things underneath the radical. For 72, I'm going to go with 9 and 8. 9 is 3 and 3. 8 is 2 and 4. 4 then is another 2 and 2. So you've got that pair of 3's comes out as a 3. This pair of 2's comes out as another 2. And then that extra 2 stays on the inside. Now we need to do our variables. And again, it looks like I'm going to run out of room, so I'm going to move this already. So again, we have an x to the 3rd. So I'm going to think of that as x squared and x. So that's going to, this pair of x's comes out. So that gives me this. So I'm going to have an x on the outside and an x on the inside. Y to the 4th, that's an even number, so that means 2 y's are going to come out. And then z to the 7th, I'm going to think of as z to the 6th and an extra z. So those 6 z's means there's 3 pairs of them, and then you have that extra z. So we have 3 z's on the outside and 1 z on the inside. And then just simplifying, negative 2 times 3 times 2, that's what? Negative 6 times 2 is negative 12. So I'm just going to rewrite this here as negative 12. Done. That's your answer. Negative 12x, y to the 2nd, z to the 3rd, root 2xz. So, that's really part 1 of this section, which is kind of like a 3-part section. We're going to go ahead and do a story problem with this kind of simplifying radicals right now, and then we'll call that video 1 for 11.1, and we'll probably do 3 videos here. So let's move down to the story problem. Alright, so story problem here. A rectangle has a width of, alright, so here's my rectangle, has a width of 3 root 5 and a length of 4 root 10 centimeters. I think it says, yep, centimeters. And it says find the area of the rectangle. Well, that's just going to be a simple multiplication problem, right? We have area equals 3 root 5 times 4 root 10. So I'm going to say that's going to be 3 times 4 is 12. And then root 5 times root 10 is root 50. But again, I know I'm going to break that right back down into 5 times 10. 10 is 5 times 2. So that pair of 5's comes out as a 5. This 2 stays underneath. Final answer, 5 times 12 is 60. and then square root of 2, and this is a story problem, so it does need to be centimeters squared, and for you guys it should be a full sentence, being as the area of the rectangle is 60 root 2 square centimeters. Okay, so we're going to call video 1 for this section because the next two kind of parts have slightly different rules to them. So right now you've just dealt with simplifying basic radical expressions. So very basic radical expressions. All right.